Let us have a discussion about why solids, liquids and gases have different properties. Because we are using the word specifically different properties, I would like to come to the conclusion that whether you take matter, I'll put it in complete shortcut. You take matter is made up of that is solids, liquids, and they are made up of gases. The solids, liquids and gases, in fact, they depend on some specific parameters, like as already I told you, the solids, liquids and gases, they depends on some of the properties, like they have some important properties. These properties we should be in a position to identify them. Whether the matter is matter because it is made up of solids, liquids and gases, the particles of matter starts behaving differently based on some specific properties. One property what I would like to highlight is that is intermolecular forces, intermolecular attractive forces, or simply intermolecular forces. That is, based on the intermolecular forces we can prove that solids are different from liquids, liquids are different from gases. Then we can also prove from one more fact that these solids, liquids and gases, they have interatomic spaces, intermolecular spaces. IMS stands for intermolecular spaces. Then these molecules, solids, liquids and gases, they also depends on the kinetic energy changes. They also depends on the kinetic energy changes. So apart from the kinetic energy changes, we can also take density, and we can also take their compressibility. So what I am trying to highlight here is, if you take these properties, if you are taking these properties of solids, liquids and gases, what I am noticing here is, for example, you take solids. In solids you find that all the particles in the solids, if you consider that each sphere is a particle or a molecule or atom, they are very close, like this. They are very close. These are the particles of solids. Particles are very close. When the particles are very close, what you are finding is the intermolecular attractive force are very strong. Here IMF stands for, IMF means intermolecular forces. Intermolecular I can use one more word that is attractive, intermolecular attractive force. And when I say IMS intermolecular spaces. So please keep this point in your mind. From the diagram it is very clear that you can see that the spaces are very less. You can see little amount of space in between the molecules, between the two molecules. You can see that there is a very less space available. This is the space which I am trying to show. This is very little space. In fact the space, the intermolecular space, this space is sometimes also called as lattice, that is interstitial lattice we call it as. Of course the word lattice is applicable only for the crystalline solids like copper sulfate, copper, zinc sulfate, something like that. So that means what you are noticing here is, in solids the intermolecular attractive force are very strong. That is, I can just show like this. You go for solids, that is strong intermolecular attractive forces, then weak intermolecular spaces, then coming back to kinetic energy, because all the particles are in the form of molecules or atoms, they are very closely packed, they have very low kinetic energy. Even if you supply the kinetic energy, when you heat depends on temperature depends on kinetic energy in turn depends upon the speed of the molecules. So if you increase the kinetic energy in solids, you cannot increase the kinetic energy, because when you are heating, the molecules only vibrate in the same position. These molecules, in fact each particle, if you consider it as molecules, these molecules, they only vibrate remaining in the same position. The position is not changed. When the position is not changed, they can only oscillate. So when they are oscillating, whatever the amount of heat you are supplying, that heat is converted in the form of kinetic energy. Whatever the amount of kinetic energy is taken by the molecules, they try to only oscillate in this fashion, and they will not change the position. When they are not changing the position, automatically the kinetic energy also more or less remains constant in these molecules, and there is no change in the movement of the molecules in the form of particles. So indirectly they have very low kinetic energy. When they have low kinetic energy, automatically they also have low speed, kinetic energy and temperature. These are the three terms where the molecules of the solids in the form of particles depends. You go for liquids. If you go for liquids, if I take one surface, solid surface, and this is the tumbler wherein which the molecules are there. So when you are trying to splash, you find that the molecules will try to occupy the surface. So that means what is happening here? Here the intermolecular attractive forces are moderate. Intermolecular forces are moderate. They are moderate. Intermolecular spaces also, they are greater. And if you take kinetic energy, yes, kinetic energy, when you heat, it increases. When the kinetic energy is increasing, the particles oscillate with the increase in speed. So therefore you find that the molecules start moving randomly in all possible directions. So you can find there's a difference. You can find some difference between the intermolecular attractive forces and intermolecular spaces between solids and liquids. If you go for gases, on the other hand, if you go for gases, yes, if you think that this is filled with some gas or some perfume gas, the gases will try to escape from the container. The gases are moving out of the container. So for gases, if you take, that is intermolecular negligible, I can say negligible intermolecular forces are there, and they have, that is intermolecular spaces, large intermolecular spaces are available, and they have high kinetic energy, and hence they have high speed, and hence they show the property of diffusion. So this is how we can show the differences between the different properties between the solids, liquids and gases in matter.